Hello, ladies and gentlemen. We're going to go ahead and look at metallic bonding today. You can see that metallic bonding is going to be involving the sea of electrons. That's why I put that little cartoon right there. All right, so metals consist of atoms that are arranged in neat rows or layers, and they're stacked on top of each other. So here we have our neat little layers, and we can see how they're stacked right on top of each other. Now the outer electrons, they can move freely throughout the metal and they become delocalized. So in this picture, we've got electrons that are represented with these little circles. Okay, and we can see that they're just going to be moving around these metal cations. Okay, and sometimes we will call that the sea of delocalized electrons, because they really don't have anywhere to go. They're just going to be moving around your cations. Now, the reason that these metals became cations is because we know that metals want to lose electrons. And metals also can be really big atoms. So it's easy for them to lose those electrons. So that's why you're going to see a positive symbol, because metals are positively charged when they lose their outer valence electrons. And these dots here are just representing those outer valence electrons. So a metallic bond is the electrostatic attraction between a positive metal ion, right here, with the sea of delocalized electrons. So let's talk about some properties of metallic bonds. And it's important that you understand what these pictures are showing you. So we already know that metals are good conductors of heat and electricity. Okay, a lot of times when you're baking in the kitchen, you might be using a metal pan. We also have metal pots, so we use them a lot of times in cooking. Now they're also malleable. So malleable means that they can be hammered down into thinner sheets. So if we look at the picture here, this is going to show you why they're malleable. So these metal ions are attracted to each other because of that sea of delocalized electrons that are in between all of these metal ions. So if I apply a force to the metal, because they're aligned in these layers, what can happen is the atoms can just slide right past each other. Okay, so they're not going to break, they're just going to be moving, so we can hammer them down into thinner sheets. Now, this picture here, which is showing heat, we know that metals can get really hot, and metals can also get really cold. So what happens is if we apply heat, that heat is going to transfer through all of those different metal ions, and it's going to be conducting that thermal energy. So this picture is just showing you how that thermal energy is going to be moving through those metal atoms. This picture here shows how we can have metals conducting electricity. So we have our negative end and we have a positive end. So we're just showing that if we apply a negative charge, we know that electrons, which are moving in between all of these different anions here, cations, we know that the negative charge is going to be repelling those electrons. So those electrons are going to be moving towards the positive end because likes repel likes and opposites attract. Now, other properties of metals is they're going to have high melting points and boiling points, and that's because of the strong electrostatic forces between the sea of negative electrons and these positive cations. And then they're also going to have high luster, meaning they're going to be really shiny, and they're going to be able to reflect.